Hello everyone, I am D.M.KALAI SELVI, Assistant Professor, CSE Department, RMD Engineering College. Subject Code 21CS502, Artificial Intelligence, 5th semester in the academic year of 2023 to 24. Now we are going to see reinforcement learning. So reinforcement learning is a part of machine learning models. So we are going to make a decision or we are going to learn based upon the sequence of decision taken. So the agent learns to achieve a goal in in an uncertain complex environment. The agent will learn or we take decision like a trial and error method. The agent either gets reward or penalties based upon the action it performs, and its our goal is to get a maximum total reward. It's a flowchart of a working model of a reinforcement learning. We get a raw input data. So if you see, you have three combination of colors, red, purple and green. So that means three different types of data are available here. Here you have three different types of data and how we are going to separate it. So if you see in the output, we have to segregate based upon the colors. So what you will do when we start with data reading, we will be starting at the agent what it based upon the algorithm, what type of algorithm going to use. Based upon the algorithm, it takes actions and it will be working on this input environment. And as a if it's going to segregate correctly, it will get a reward, otherwise it will get a penalty. So after segregation, finally, like a loop, it will be working at again and again until it reaches the goal state. So the goal state here is to segregate three different colors completely. So then it will achieve the goal state and it will be come out. So here reinforcement learning is you're going to learn via the experience the agent gaining from the task environment. So we have two types of reinforcement learning, passive reinforcement learning and active reinforcement learning. In passive, the agent's policy is fixed and the task is to learn the utility, or you can say it's the uses of each state, and it also involving a learning model for the environment. In active reinforcement learning, the agent also learn what to do. So you can say it in active reinforcement learning, exploration of or agent can experience, and based upon that experiments, it can able to know how to behave in it. The main terms used in reinforcement and learning. Input will be a set of initial state from where the model is going to start or the agent going to start. Output will be the many possible ways for the agent to react, and we will be setting one thing as a solution or a goal state based upon the reward. So training is based upon the input, and the model is the agent will be undergoing the training using a specific algorithm, and the training will be done for the entire the input data, and the agent is working correctly will be determined by the maximum rewards the agent is going to get, and that will be the best solution. And based upon that, it will be continually reading and learning the it gains the knowledge by learning, continuously learning. Now we are going to see Markov's decision in reinforcement learning. So first we are going to represent the environment. We have finite set of states, yes, and we have a finite set of actions, A for each state, yes. And then process at each discrete time speed, the agent going to observe a state and then take a necessary action. After that, after the action, so what the change is going to, but that is we are going for a reward or a penalty. So initial state will be yes, no. Transition state will be S, start from yes. We are taking action A and we are getting a output as S dash. That is, we are going to the next state S dash. So reward R of S, if the because of this transition we are the agent receives a reward means then it will be R of S. So the Markov property is if you are doing the transition functions and the rewards only depend upon the current state, yes, but not on the any state visited earlier. So it won't depends upon the previous inputs. It only works on the current input and the corresponding action. So if you take this Vampus example, the robot here, if you say that robot want to get a diamond, that is our ultimate goal and that will be our maximum reward. So if the next to see you have fire, so without entering into that fire, the agent has to get the diamond. So if the agent moves like this, that is from here go straight, then left, left, and then goes here. If it uses this part, it can able to get the solution. I mean, get the reward, and so he going to identify it based upon the experience again by moving to the each cell here. So if the agent is standing where it going to start, it will be the initial state from yes. So this will be the state yes. And it moves to the next state S dash by doing action of move. So the action will be move, move straight. So if moving here and if you have a fire means then the next cell will have that hot breeze. So if here you don't have a hot breeze and here you don't have a hot breeze and using that hot breeze you can able to get that reward. So based upon moving from one state to another state based upon the experience it gaining, it can able to get the reward and finally achieve the uh, solution, and I mean finally finishing the game. So this is an example of a passive one. If you are taking an active one, based upon the robot movement, if the cell, this fire one, right, if it is moving on dynamically, so your work will be moving on dynamically. If you take example like temple run, moving on, the obstacles will be changing. So in that type of game we called it as an active reinforcement learning. So reinforcement learning mainly used for gaming environment. So the robot, that means the player will observe and take necessary action, and the final aim is to win the game. Thank you.